Welcome to the video lecture. Today I am going to explain about autotransformer. Autotransformer is a transformer, it have only one winding. Normally know the two winding transformer. Sometimes you want to synchronize or rather connected the lines between the 132 to some 138 kV, like 220 kV to or 200 kV, like that. A small voltage variations are available at the time. Compared to the two winding transformer, auto transformer is very useful, and also it is more economical and advantage. For example, like a two winding transformer, you know, two winding transformer, this is the two windings. Generally it is the primary voltage, develops secondary voltage. Here n number of turns primary side and number of turns on the secondary side. Once you connect it to the source, it draws a current IP, and once you connect it to the load, it delivers IS. This type of transformer you want to connect it as a single winding nature. Now the primary is taken as a common winding. For example, this is the common winding. We can call it as NC, and secondary winding is treated as a series winding to the primary. This particular polarities, we know that we are connected in series. This is NSC. Now this winding is connected to like this. It is act as a step up transformer, but it is only one winding. On this across this winding develops some voltage, that is called common voltage, and across this series field winding develops some of the voltage called series voltage, and this voltage called as low voltage side VL. For example, this is called as a VH. So primary side current, low current, this is called low voltage side current, and this is called high voltage side current. But how to give the relations here? Just have to give the now maybe it is the primary terms you are using like a common terminals NC, this is the NSC. Across this voltage called as some VC, this is called as a VSC. Now VC by VSC, it gives in the two winding transformer, then generally the ratio of their number of turns NSC by NSC. Similarly, yes, this is the way of connections. But in here VL is equal to, in auto transformer, VL is equal to across the common winding, that is called as VC, but VH is equal to this winding common voltage plus series voltage VC plus VSC. This is the voltages like that. So currents are how to passing that. What is the IL value? Here IL is it is splitted here. Why? Because compared to IH, IL is more. Why? Because it is a step up transformer. Low voltage current is more. The total current is sum of the current passing through series winding, that is called as ISC, and remaining current is passing through the common winding, that is called as IC. Here the IL is equal to, what is the value? IC plus ISC. Similarly, IH is equal to IH and series field current is same, series winding current ISC. So these are the links between the winding auto transformer. Like that, this is the step up and step down also. In this manner we have to connect, and Now voltages and currents in autotransformer. Same, I have to take the step up nature, taking here series field, series winding and common winding. We are connected here like this. This is the common VL, VH, and this is called as IH. This is called as IL, NC, NSC. These are the number of turns. These are the main, and we are going to this current is this is a common current, and remaining current IS is going like this. My question is, what is the value of VL by VH? VL by VH, generally in the previously we are writing this all the terms. VL is equal to VC, and here the VL is equal to VC, VH is equal to VSC plus VC, common voltage across this one, and IL is equal to ISC plus IC, and IH is equal to, once again I rewrite this all these things, ISC. This is common values. Now what is the relation between the number of turns in the autotransformer? How can I write it? We take it VH is equal to, for example, voltage relation I am writing first, VSC plus VC. We know the two winding transformer, VC by VSC is equal to NC by NSC. Now I want to calculate here the VSC values, VC into VSC is equal to VC into NSC by NC. This value substituted here, we are getting VC into NSC by NC plus VC. We take it VC common, so that means NSC by NC plus 1. You know the VL is equal to lower the common voltage, that's why this is simply can write it VL into NSC plus NC by NSC. So you have to relate it that VH by high voltage by low voltage is equal to VH by VL is equal to NSC plus NC by NSC. This is the voltage relations in autotransformer. Similarly, we have to use current relations, IH by L. How can you calculate it? We are getting the just you have to take it here. Here IL is equal to IL is equal to ISC plus IC in the transformer. IL is equal to ISC plus IC. So what is the relation here? ISC is equal to, you know, this MMF. IL is equal to ISC. We related that VSC by VSC is equal to NC by NSC. Similarly, once vice versa, voltages are VC by VSC, that means it is equal to ISC by IC. In the common rule, voltage, suppose it is step down, current is step up. So current step down, maybe suppose voltage step up, current step down, voltage step down, current is step up. So low voltage at high current is available, high voltage at low current is available. This is the common rule of this equation. Based on that, we using this equation here. What is the you can write it IC value here. How can you write it? IC IC value we can write it in terms of ISC. In terms of ISC, IC is equal to ISC into IC is equal to IC is equal to ISC into VSC by VC. VSC by VC, simple. So VC IC is equal to ISC VSC. So voltage comes, based on that we are getting. So we substitute this here, and what is that? IC is equal to ISC plus ISC into VSC by VC. But ISC plus ISC, but VSC by VSC is nothing but NSC by NC. Both are equal, the ratio. Now ISC is common here. Now we are getting 1 plus NSC by NC. Here ISC is equal to what is the two winding transformer? ISC is passing through the high voltage current. So that's why here IH is IH into NC plus NSC by NC. This is the formula. Now I can conclude here IL by IH is equal to NC plus NSC by NC. This is the one of the equation. It is the current relation in the auto transformer. Similarly, here we are getting the VH by VL is equal to VH by VL is equal to NC plus NSC by NC. So low voltage current by high voltage side current is equal to NC by NSC into NSC, or otherwise high voltage by low voltage is equal to, it is related of common number of turns, common turns plus series winding by common turn. This is the relations of the auto transformer. So another important point in auto transformer, per turn voltage is same. We can take it a single, like per turn voltage is same. So that's why how much it is variably we are operated. So we are considering for from 0 voltage to or 120% rating, we have to change, right? Per turn voltage both side is same. That's why number of turns are increased. So automatically output side the voltage is varied in this manner. This is also auto transformer. Another important point in auto transformer, their capacity is normally for low range of the voltage ratio is very less. At that time it is very advantage compared to that. At that time general auto transformer is used. You have to continue in the next class for that how the their capacity, apparent power is different from input side to output side, and especially for the winding capacity. Thank you.